Type 2 diabetes, also known as adult onset diabetes, is a metabolic disorder characterised by high blood glucose. Obesity is thought to be the primary cause of type 2 diabetes in people who are genetically predisposed. Thus, overweight people have increased levels of glucose circulating in their blood. The pancreas is an organ which produces hormones that control blood glucose levels. The hormones that control blood glucose are produced by clusters of cells in the pancreas called islets. Here glucose is shown arriving at the islets via the bloodstream. The glucose is taken up by cells in the islet called beta cells. The beta cells respond by producing the hormone insulin, which lowers blood glucose. In type 2 diabetes, high levels of glucose stimulate the beta cells to produce lots of insulin to lower the blood glucose levels. The insulin is taken up by the blood vessels for transport to muscle, liver, and fat, where it allows those tissues to absorb glucose. Unfortunately, sustained production of insulin also leads to secretion of large amounts of another hormone-like substance by the beta cells. White blood cells, which live in the islet, respond to this hormone and consume it. We are now inside an islet white blood cell at a magnification of 250,000 times. The hormone, in combination with high glucose, causes production of free radicals inside the white cell. The free radicals activate a sentinel protein that originally evolved to protect us from microbial infection, causing it to unwind. The newly active sentinel proteins then aggregate with 6 other proteins to form a ring. Seven adaptor proteins then bind to the ring. The adaptor proteins work to capture specialised inactive proteins from the surrounding cell fluid, bringing 2 halves together to form the active whole, which is then released. This entire structure is called the inflammasome, and its sole purpose is to act as a platform for combining and activating these proteins. The newly active proteins then convert yet another small signalling protein, splitting it into its active form. This protein is the key protein involved in inflammation in the body. The inflammatory protein is then secreted from the white blood cells into the islet. Unfortunately, this inflammatory protein causes death of the beta cells. Over time, beta cell death causes the islets to shrink, accelerating disease progression. As the islets are now greatly reduced in size, they cannot produce enough insulin to control blood glucose levels. Over time, high blood glucose causes damage to many different tissues throughout the body. What originally evolved as a defence mechanism against infection now seems to be a driving force for inflammation in type 2 diabetes. Chronic diseases associated with inflammation are the most common diseases of ageing in the Western world and represent our greatest health threats in the 21st century.